So hello, this video is a quick demonstration of the cloud computing assignment. This was a 1 month project. So let me present my screen and actually tell what exactly it was. So you can get the GitHub source code. I will attach the link in the description. And this was basically a multi-cloud e-commerce platform that I need to design, right? And it has several microservices. It has event-driven architecture of Lambda. It has also Kafka. I'm using Confluent Cloud. It has two clouds. One is AWS and another is GCP, and both are communicating via Confluent Cloud. That is our Kafka, right? And there are RDS. There is DynamoDB. We are using 6 microservices. We are also using Argo CD. So this video is a complete end-to-end demonstration. This video, right? So I have trimmed some of the parts of the end-to-end video to not make it very long. And if you want to have a full assignment, you can go to the source code and also you can click on the assignment, right? So you will get a whole overview of what the assignment was, all the points that need to be covered, because this was actually one of the big project and worth documenting it. Also it has also, if you go to the main readme, so main readme is self-explanatory, and you can have a point A, point B, like all the that were points mentioned in the document. So yeah, all individual points of the assignments have been covered, and also we have a readme for individual points. Also, after deploying it, I have destroyed the Terraform architecture so that I don't get cost anymore. So yeah, the main purpose of the video is the demonstration of the project, the assignment. I hope you will enjoy it. You will learn something new. If you have any doubts, you can comment. You can ask in the comment section. If you want to build something like this, you can go to the assignment as I shared, and you can go to the individual points, make something of your own, and also you can refer my code base because it's open, so you can see the modular approach. Also, I have done vibe coding, but AI sucks when it comes to deployment at all. And now let's better proceed with the project demonstration. You will get the idea. So today I will demonstrate the last point, a video demonstrating end-to-end working of your application, including the test phase. So we will go through all the setup, how everything is connected, right? So giving a brief overview from the design part. So in our AWS cloud, we are using microservices in EKS cluster, right? And our separate cloud B is our GCP, where we are using Dataproc. So in AWS, we are using EKS for hosting our microservices. So there is a API gateway microservice which routes to user service, order service, product service, payment service, and there is one analytics service that is hosted on our Spark job, that is our in GCP, right? And uh, talking on the internet side, so for from the internet we have attached in our VPC internet gateway that comes, which routes to application load balancer, and from application load balancer we go to the API gateway, and from API gateway the services go, and the inter microservice communication is using REST API only. So order service, whenever a user service and product service are independent service, they are directly accessed by API gateway. Order service also talks with user service and product service internally by by REST framework only. So whenever an order is created, whenever an order request comes, it validates if the user exists by calling user service, and validates product exists by calling product service. And on the database part, for order service we are using DynamoDB, for payment service we are using DynamoDB, right? And for user service and product service we are using RDS. Also, our EKS is inside a private subnet. Only the application load balancer is in public subnet, and also the outbound traffic goes via NAT gateway. So our database RDS which we are using, is also in private subnet and separate private subnet. Then we have ECR also. We are using ECR, uh, uh, where all the Docker images are stored. So whenever a developer pushes the code in the GitHub, we will go to the whole setup. We will demonstrate it in a while, but explaining it from the overview point of view. So whenever developer pushes the code, the Docker image is built in the pipeline and it's pushed to the ECR. Then also the GitHub updates the image tag by an action commit. The individual points that were there of deliverables have already been shared via this link. So if you go to the README, and if you open this point by point video demo, so you will get the whole video explaining each point in depth. But this is the main overview point of view. So yeah, once the image is updated, the Argo CD pulls the latest image from the GitHub and updates. So there is no kubectl deployment we are using. We are using Argo CD for a deployment. And also once the order is created, so once the order is created, after checking the user service product server and finally storing through the DB, two events happen. One is the order event, it goes to the SQS, right? So SQS, and from the SQS, a Lambda is triggered, and after the Lambda is triggered, a notification is stored to the AWS DynamoDB. Previously I was using SES, but it was giving me domain trouble and also finally decided to store it in the DynamoDB notification only. Then we can use it later on. So yeah, the step is like the one event driven step is like this: the Lambda invocation by SQS, right? And the order service goes publishes to the SQS, right? Then there is one more event: order service prod- uh, uh, pushes the event to the Kafka orders topic, and which is maintained by Confluent Cloud, right? So the order service pushes to the the order service pushes the event to the orders. Right, so Kafka has, we have demonstrated, have two topics: orders and analytic result. We will go hands on everything in a while. Like we will show that there's also, we have Bruno. I have set up the Brunos for API documentation. It's like Postman only, so but we can have a Git history. So we are using all the services, order service, right? And on the Dataproc side, we will demonstrate that also. So we have two: analytic result, orders, cluster, and Dataproc, how it's all working. So just explaining it from the broader level right now. So once the order is published, it goes to the Dataproc, and in the we also have GCP. In the GCP we have Dataproc, our cluster, which has a Spark job, and this job is we are using in a cloud storage, GCP storage. So we store Spark job, orders analytics.py. You can check the code. You will find the file order analytics.py that has the code which uses this, and e-commerce analytics checkpoints. So yeah, we are using Dataproc for that. So it's a multi-cloud setup, and it's connected via Confluent Cloud Kafka, right? And once the process of the time aggregation is done, right? So basically, what happens in 1 minute? How many orders of unique users are created? They are calculated, and they are uh, displayed in the Apache, and also they are stored in the analytic results topic back to the this. And from the analytic results, we store it back to the AWS S3 bucket. So this is the whole cloud setup, right? Now let's go to the demonstration one by one, exploring each thing in depth. So as one of the requirement was the ID must be mentioned. So yeah, Ayush Gupta 23A5 PS1185. So this is the terminal. I have split it into two halves. So now first explore our cluster only. So if I do, I have attached it actually to the uh, my AWS only. So AWS EKS. So if I will first of all show all the nodes, so we are using three nodes, right? These are T3 medium. So I also, if I want to show you, I can show it from the console too. If I go to EKS, e-commerce EKS, uh, resources, we can see from nodes, cluster nodes. We can actually directly see from EC2 also. I don't know why it's not showing it here. Instances running. So these all three are managed by EKS only. So this is the cluster. Okay. Also, we are using Grafana. That was one of the requirements. So we have met all the requirements, and all the requirements, point A to H, are all being displayed in that one video, detailed explanation. Now, today we will explain the overview only, right? So these are the nodes. If I look on the pods, so if I go with kubectl get pods, let me do all namespaces actually. So we have Argo CD, right? Argo CD we have installed. Then we have our e-commerce, we have API gateway, order service, payment service, product service, user service. Then we have kube system. Then we have observability stack. So these are all the things that are running in our EKS cluster right now. Now, let me also show the database side. So we are using DynamoDB, as I said, and we are using RDS. So if I show AWS, let's show DynamoDB first. So if I show all the tables of DynamoDB, we can list the tables, region, and this is my account profile, right? So these are the e-commerce cart, orders, payment, and notifications. So orders is directly linked. Which we are using. Payment is directly linked. Notification is what is being triggered by uh, what you say, Lambda. Also, I can show it on the console. Um, Yeah, here only. So notifications, e-commerce carts, e-commerce orders. So this is what we are using DynamoDB for. Now let me show RDS also. So to show RDS, since RDS can't be directly connected, we will run a pod. Actually, I have run a pod, PG client. So this is this we will run a pod inside the cluster because the cluster and that are in the same VPC, right? So that would be able to connect, but because RDS is not publicly available for the security reasons, right? So let me exec into my uh, pod. See, this is the pod I'm talking about in the e-commerce PG client. So this is nothing but a normal Postgres image that is running. But because now we can connect, it's in the e-commerce namespace in our cluster in our same VPC, so we can connect with the database, right? So let me actually, I actually ran it previously, so it must be in the history kubectl. Yes, so we are inside the RDS display table. Oh, sorry. Yep. So we are using users. And if we select everything from users, select star from users. Uh-huh. It would work now. So yeah. So we have users, John 11, John 12. These are all the test users that we create. We will create new users also, and we will test the whole flow. The whole flow is that when we create a user, then we create an order, user validates, validates, product ID must be there, user ID must be there, and once everything is there, user it would be created. We will check the SQS setup is working properly, SQS to Lambda to this, and then the our main intra cloud inter-cloud communication, that is from AWS to GPC via Confluent Cloud, right? So let's now proceed with, we have explored the databases. Also, we are using S3 that I told. We can explore, where's the console? We can have S3 also. So we are using S3 for different purpose, for storing the results. Also, we can store images and all if we want. So we have e-commerce product, e-commerce analytic results that we are storing, right? So now actually let's proceed. Also, we can like Kubernetes monitoring. We can monitor our. Also, we can have monitoring enabled, and we can also see microservices logs at all one places. Product service log, order service log. So we can do that also. So all the logs are of the all the microservices at one place using Loki and Grafana. So that is also one thing. So now let's explore. Now let's create some order, create some user, and then we can proceed. Also, before creating some order, let's also explore another thing. That is our services. So the setup is normal, and you can find all the code in the service if you, in the manifests file, right? So if you go to K8s, you get to base and all the services and all that are being created, right? So there are services also. Of course, there will be services to expose, and we are using internal cluster DNS resolution for that. So e-commerce. So we will get the services: API gateway, order service, payment service, product service, user service, right? And also we can get the HPA. So kubectl get HPA minus n e-commerce. So we have defined two HPA. That was also the requirement. We will test HPA also in a while. Now let's proceed with. So first check the pipeline setup that it's working. So let me make some code changes. What I can do is maybe go to order service. How the Argo CD and all is working. That is all explained in the detailed one video, right? So we can go to order service main.py, right? And in that actually we can add some debugging information maybe. So we can have that create order function. There is one function create order. Yep. We can add just simple one line. I mean we can add a logging line. So let's add a uh, logger dot info that we are creating an order. Yeah, works. Now let's actually is logger imported by the way? Yeah, we are using. Yeah. So what we can do is get status. Yep, done. So now if we visit our GitHub, let me refresh it. See, this actions tab. and our action is running. So what it will do, it will build the order service and then it will update the customization with the image. So meanwhile, we can also check the ECR images, right? So we can describe AWS, ECR, describe images, right? E-commerce order service output in table format. So the last e-commerce order service image tag is DD7, last digit. Literally, sorry, 34345, 34F5. We will wait. We will wait for the deployment to proceed, right? It's running. The one job is completed. We can ETL um, get pods minus n e-commerce order service watch. Yep, one ready running. Once it would be complete. Oh, it's completed. So Argo CD typically takes 1 to 2 minutes to poll the changes. It will poll, right? That's why we are using Argo CD. And if I go to commit histories also, you will see that action user has committed. So we made this commit, right? And then action user committed with this. It has just updated the tag. It has updated that 34F5 to our latest tag, image tag. Now, if we click on the ECR, right? See, this is also terminating and rerunning because it has Argo CD has automatically polled the changes. We didn't did anything, right? Deployment is being done automatically. See, 77468. This is the ID. This. So it has updated. ECR has pulled automatically, and Argo series noticed that, oh, there is a change in this, and we are watching it for that file. And you can check the whole code in the individual folder, individual video that I uploaded, right? The 40-minute video. So that could be seen, and this will terminate and restart the pods. So yes, our latest pod is now running. So this was one thing. Now, since we are clear with the CI/CD setup, now we can proceed with the end-to-end testing. So let's get the API gateway. So API gateway URL I have actually it's recording. So if I go to the environment configure, see this is the URL, our URL for the application load balancer. Which application load balancer? This application load balancer, right? So this is exposed to the API gateway. Other services are all internal services that are talking, right? Internal APIs are also order service, payment service that are order service calling individually via that. Okay, now we can get, let's, rather than using Bruno, let's actually directly do it from, let me close this tab. Yep. So let me actually do it from the, that also. So, and I don't have to repeat. So I've copied the commands in my notepad. So first we will get the API gateway, right? Now we have got the API gateway. Now we can create the user. So we can create the user. Let me change live user test, right? This is my phone. This isn't my phone number, by the way. I don't know. Like, let me type anything. Okay, live user test, live user at example.com. Cool. Now we can enter. So user response is there. So user response is actually done. So let's, yeah, echo it. Okay, this is just for like beautifying it in JSON format. So we have got the user ID that we will use for the order creation. So now we can also verify it by in the database, but like it has created. I'm not exiting in the pod again and accessing the table. So we know that it's working, right? And order table would be in that DynamoDB. So now let's create the order. So user has successfully created. Now create the order. We can copy this. We have stored the user response, order response, right? We will create for this product ID. We can list all the products, by the way. We can list all the products. We can go to product, get product, just hit the API. All the products are there. You can use any product you want. And let's enter it. And uh, several things are going to happen right now. Now that one is that, where is SQS would Lambda would be triggered and Dataproc would also be triggered. Right now the batch 31 like it shows nothing, right? Now it would. So if I do enter order response done. Now if I go to Lambda, order is created because where is Lambda? This SQS is triggering this Lambda function. Now go to the let me go to this, access the latest one. See, this has actually done its jobs found credential. It has run right in this time only 11:26, the today's date. And now oh, by the way, yeah, we can monitor the logs here also. Order received, API gateway, product service, right? So uh, this was another user created. So all the logs could be uh, seen here. It's working perfectly fine. Now what we can do is we can check the DynamoDB. We can check the DynamoDB. Where is DynamoDB? Yep. So if I refresh it and sort it by time, uh, yep, time 26. This is the latest order that has been created with a SQS Lambda. This also I have one script, so we can actually monitor it more orders. So that this will basically that script would basically generate a lot of orders. So if I go to my desktop, my home, change directory desktop, right? I have this script demo point e.sh. So this basically creates dummy orders for us. So let me process it. Chmod. We will give the permission and then run it. Okay, so it will create 20 orders. One order created, two orders created, three orders. Okay, quantity is also there. So it is just creating orders. And now, if we will refresh, we see batch 32. We can see this unique user for that 1 minute window. Okay, some like it insufficient stock. Never mind. But yeah, we can see for the 1 minute time window that was previous one window. This is current one window. The it's working, and we can. It's also publishing back to the topics. We can see the orders that were created at latest at this time, right? Order created, and if we go to topics, we can see analytic results also. So that messages are being published from there here from the Dataproc to this. So it's like two-way communication, right? Let me show. Yeah. So we have demonstrated how this works. We have demonstrated how this is working, DynamoDB Lambda, and we have demonstrated that it goes to the orders, goes to the Spark. Spark, we have seen the logs, and comes to the analytic results. And yes, so this is the whole setup. ECR, we have seen this also. We have seen this. We have seen this. So this was the complete setup of the end-to-end project demo. So I hope this was clear. Also one thing we can also demonstrate HPA we missed. So only 1% order service. Right now, if I get the all the pods, right, pods we will watch. So there are only one pod for the order service, and we will hit our K6 test in the order service. So what this script does, it creates fake traffic for the for our orders URL. It will create some order traffic, and we can see. So the duration would be 30 seconds, then 3 minutes, then 1 minute. So it will ramp up, sustain load, and then ramp down. So yes, let's see the traffic and how it all connects together. So now let me hit the loud. Right now it's like, if you can see, it's one by one, right? And also the CPU utilization for the order service is 1% only. Now if I just hit this service, now watch. Replicas 4, order service replicas are 4 now, right? Why? See, these are being created as the traffic is increasing. We can see that order service increases. See, it's now replicas are 4 for the order service, and this utilization is 62%, which is order service is 62%, which is above our threshold, right? 15%. So it has increased. See the number of pods that are being created. Order service, order service, order service. It will reach the max. It will reach the max, right? It has actually reached the max. Now the replicas are 8 from 2. So our test is performing K6 test, load test, and the pods are being created, pending, created, right? And we can see that clearly that this is working absolutely fine.